Hello, folks. This is Shraddha Bharti, and I welcome you all to yet another lecture on project management. And in today's lecture, we are going to do a question based on crashing of a network diagram. The question has been asked in the ESE examination, worth 15 marks, and trust me, it was the most difficult question I have ever encountered. If you can solve this question, I'm quite sure you will never face any difficulty in any of the questions regarding crashing. So, without further discussion, let's start our question. So, the question says that determine the minimum and the optimum cost during and the duration for a project network. So, there are three things we have to find. We have to find the minimum and the optimum cost of the and the duration for the project network. The duration and the cost of each activity of the project is given in the following table. So activities are given, normal duration is given, normal cost is given, then crash duration is given, and crash cost is given. The indirect cost of the project is rupees 800 per day, and it says that draw the time scaled version of the network diagram. So let's first understand the question. So activities are given, normal duration is given, and then crash duration is given. Crash duration means it is that duration which we can reduce our activities. Like a 7 day activity can be reduced to 3 days for 3 days, but there will be an extra cost for such thing. So if an activity AC is completed in 7 days, the cost for activity AC will be 5,000, while if it is completed in 3 days, there will be an extra cost and it will cost rupees 9,000. That means there will be 4,000 extra. Okay, so this is the concept of crashing. We have to crash the network. Let's understand what are the steps behind it. The first step is that we have to find the cost slope. Don't worry, I'll discuss what a cost slope is. Then we have to draw a network diagram and find the critical path, the next step. And the final step is draw the time scaled diagram. This also I'll discuss. And then start crashing with the activity having the least cost slope. Okay, these are the three steps in the crashing. So let's proceed with the step number one. What is the step number one? Step number one was to find the cost slope. So I have replicated the entire table over here. This was the table given in the question. So activities are given, duration is given, normal duration. This is the normal cost, this is the crash duration, and this is the crash cost. Okay. Now we have to find the cost slope. For finding the cost slope, we have to find delta t. What is delta t? Delta t is uh, the normal duration minus the crash duration. So crash duration is always less than the normal duration. So it will be delta t is normal duration, normal time minus the crash time. Okay, if you want, you can write it down. Crash time. So 2 minus 2 is 0. 7 minus 3 is how much? 4. 6 minus 3 is 3. 5 minus 4 is 1. So like that, we'll complete the table of delta t. Now what is delta c? Delta c is the difference between the crash cost and the normal cost. Now we know that crash cost is always greater than the normal cost. You can observe over here 9,000 and 5,000. So crash cost is always greater than the normal cost. So it will be crash cost minus normal cost. Okay, so it is 10,000 minus 10,000, that is 0. 9,000 minus 5,000 is 4,000. 4,200 minus 3,000, it will be 1,200 if I'm not wrong. So like that, we'll fill up the table. Now this is called cost slope. It is delta C by delta D. This delta C, that is the crash cost minus normal cost. Delta T, that is normal time minus the crash time. We have to divide it like delta C by delta T. 0 by 0, which will give us 0. 4,000 divided by 4 is 1,000. So we'll fill the table like that. So what exactly is cost slope? Cost slope means cost per unit time, the extra cost that we have to pay per unit time, that is per unit day or per hour extra. you can say, or per week, whatever it is, per unit time for crashing the network. Crashing the network means for reducing the time duration. If we want any work to be done quickly, we have to pay, we have to apply extra labor force. So for that extra labor force, we have to increase the payment, right? We have to bear some extra money. That is the cost slope. Cost slope is cost per unit time, extra cost per unit time. I hope this is clear to you. Now I'm not filling the entire table because I have done already. Here is the filled table. So here step number 1 is done. So what was the step number 1? To find the cost slope. Cost slope uh, for AB network, it is 0 because it cannot be crashed. For the AC, it is 1000 rupees per day. So if we want to reduce the time duration of activity AC, we have to spend 1000 rupees per day for crashing each day. Okay, BC is 400, similarly BD is 500, and so on. So this is the first step, that was finding the cost flow. The next step is drawing the network diagram and finding the critical path. So since the network diagram was very easy, I'm not drawing it again. I have already drawn it for you. Those who have difficulty in drawing the network diagram, I'll request them to please go through my previous lectures where I have very elaborately explained how to draw a network diagram. Okay, so in this, I have already drawn the network diagram. So this is AB, AC, BC, BD, CD, CE, DF, and EF. See that CD normal duration is 0. That is why it is a dummy activity over here. So let me write the normal durations over here. Normal duration is 2 days. So I have written all the normal durations over here. Now the next step is to find the critical path. So for finding the critical path, we have to follow the same procedure. So what is the procedure for finding the critical path? It is, first you have to go through forward pass, then backward pass, then you have to find out the slack, and then the activities with minimum slack will be critical. So let's do that. Let me change the color first. Okay, so let me start with 0 time. So I'm going through the forward pass. It is my convention that I write all the earliest expected time on the top of the node. So this is 0. 0 plus 2 is 2. I hope this is very much clear to you, students. I have already taught you this in the previous lecture, how to find the critical path. And those who are not aware of that, so please go through my previous lectures to find out how to find the critical path of a network diagram by forward pass, and then we have to go through the backward pass. 0 plus 2 is 2, 2 plus 6 is 8, but here 0 plus 7 is 7, so we'll take the maximum one is 8. Now let's proceed to 8 plus 9 is how much? 8 plus 0 is 8 and 5 plus 2 is 7, so we will take maximum of these two, that is 8. Now 8 plus 11 is 19, but 17 plus 6 is uh, 23. So we'll take the maximum of these two. So it will be 23 for here. Now we'll go through the backward pass. So let's continue with the backward pass. So we'll replicate the same number over here, 23. 23 minus 6 is how much? Is 17. And 23 minus 11 is how much? 1 to 12. Now 12 minus 0 is 12, and 17 minus 9 is 8. So we will take the minimum of these two. Now 8 minus 6 is 2, so we'll be putting 2 over here. Now 8 minus 7 is 1, while 2 minus 2 is 0. So we'll take the minimum of these two, so it will be 0. Now let's find out which is the critical path. So for that we have to find the slack. Slack is nothing but the latest allowable occurrence time minus the earliest expected time. I hope you remember all these things. We have already learned about these things in the previous chapter. So 0, it will be 0. 2 minus 2 is 0. It is 8 minus 8 is again 0. 17 minus 17 is 0. 23 minus 23 is 0. While 12 minus 8 is 4. Right? So I think we have got our critical path. It will start with A, B, then it will approach to C, then E, and then F. So our critical path is A, B, C, E, F. Okay, so this step is done. Now let's proceed to our next step, which is drawing the time scale diagram. This is step number 3. So for drawing the time scale diagram, it is very important to find the critical path A, B, C, E, F. Okay, and see the duration. How much is the duration? It is 23 days. So for drawing the time scale diagram, what I have done, I have made a time frame, a time range of 23 days over here, which is equally spaced. Now I'll draw the critical path A, B, C, E, F. Right? A, B, C, E, F was this path. This path I have drawn like this. This is a time scale diagram. So the arrows and the node should be exactly above the time. Like A is starting at a 0 time interval, while it takes from A to B, it takes 2 days, right? A to B, it is 2 days. So exactly after 2 days, B will appear. So here it is 2 days. Now from B to C, it is 6 days interval. So exactly after 6 days, C will appear. CE is 9 days. So 9 days means 8 plus more 9 will give you 17 days. So it will take 9 more days. So look here carefully. E is just above 17. Similarly, EF is how many days? EF is 6 days. So 6 more days will take you to 23 days. In a time scale diagram, this critical path is drawn in a straight line and all the other parallel things are drawn accordingly. Like we have to draw AC. AC is taking 7 days. So see here, AC is taking 7 days. Now another important aspect of this is here just above 7, I have drawn a solid line. So this means it is 7 days for from here till here. But what after that? It is a dashed line. Dashed line says that because I have to connect A to C. So I cannot extend this solid line till C because it is taking 7 days. So I can draw the solid line till 7th day, and from 7 to 8 it is a dashed line, which means that it is a float. It is representing a float or a slack or the extra time for the activity. Okay, this aspect is very important. Now similarly, look here from B to D. BD is how much? BD is 5 days. After 2 days, we have to add 5 days to it. So from B to D, it should be 5 more days. If I go from 2 to plus 5, I should get at plus 7. So till 7, I can draw a solid line, and this one day I have to draw by dashed line because it represents the float of the activity. That means it is the extra time. And activity D is starting at the 8th day. Earliest expected time is 8th day. So I cannot draw D here. I have to draw D here only, just above 8 mark. Similarly, F activity, I cannot put it anywhere else but at the 23rd day. So I am putting F at the 23rd day, but from DF it will take, DF takes 11 days. So from 8 to 11, it is 19 days. So till the 19th day, I have drawn with a solid line. And after that, I have drawn with a dashed line to connect till F, which means that it is a float for this activity, DF. This is the surplus time, extra time. Okay. The concept of float and slack I have also already taught in the previous lectures. So please go through that. Now, this is the same time scale diagram. for the project. Here I have written all the, this is the normal time and this is the crash time. This is the normal time, this is the crash time mentioned here. So what is the normal project duration? Normal project duration is 23 days, right? 23 days is the normal project duration. What is the direct cost involved? It is given in the question. Direct cost involved, it is given in the question. So I have already added all these numbers, and it is 39,000 if the project is completed in 23 days. It is 39,000 for direct cost for the project. Now, about what about the indirect cost? Indirect cost, it is also already given in the question that indirect cost per day is 800 rupees for each day. For 23 days, it will be 23 into 800. That will be, sorry, 18,400. So what is the total cost of the project? Total cost of the project will be 39,000 plus 18,400. That will be 57,400. Now let's start with the first stage of the crashing. There are two things to be kept in mind. We have to start crashing with the critical path, and here the critical path is this one, A B C D, A B C E F, and second with the least cost slope. This was the cost slope which I had calculated earlier. So activity which is having the least cost slope is 0, right? But we cannot crash AB because there is delta T is 0. Delta T is 0 means there is no scope of crashing it. Normal duration is also 2 and the crash duration is also 2. So there is no scope of crashing it. So we'll look for the next minimum cost slope. That means minimum amount per day we have to spend for crashing. So next minimum amount is rupees 400. And this can be crashed for 3 days, BC. So let's start crashing BC, and the cost of crashing is 400 rupees per day. So this is BC. Now here the question is, can I crash it for 3 days? Look here carefully. If I crash it for first day, it will become 5 days, and meanwhile AC and BD, these two are parallel to AC, so these two will also get crashed. But these two activities, AC and BD, are having a float of 1 day. That means extra time. It will not cost extra for crashing for if I reduced 1 day for these activities, right? This is the extra time. And if we crash it for 3 days, it will these activities will also be crashed. BD and AC will also be get crashed, and the cost will also be involved. So we cannot crash it more than 1 day. Why 1 day? Because these activities were having float for only 1 day. Things will become much more clear when we uh, proceed ahead, okay, with the crashing. So don't you worry if you didn't understand it right now. I'll repeat the same things again and again in the further stages of crashing. So I will just crash it for 1 day. After crashing it for 1 day, what will happen? You see, C activity was starting at the 8th day. It will start from the 7th day onwards. So I have made C on the 7th day onwards. Meanwhile, the activity D, which was also at 8th day, it will come to the 7th day. And this AC activity, which was having a float of 1 day, extra time of 1 day, the float will be gone. There will be no float available for AC as well as BD. Now let's see what happened after the first stage of crashing. The new project duration is only 22 days. So C is getting shifted to 7. Similarly, E, which was earlier starting at 17th day, look here, E, which was earlier starting at 17th day, will get shifted to one place before, that is 16th day, and F, which was ending on the 23rd day, it will end on the 22nd day. Look here, E is getting shifted at 16th day and F is getting shifted to 22nd day. Rest everything will be same apart from that BC, which was for which the normal duration was 6 days, it has converted to 5 days only. Okay, so the new project duration will be 22 days. Now the what will be the direct cost? Direct cost will be 39,000, which was the original cost of the project, plus surplus 400 for crashing BC for 1 day, take you to 39,400. So the direct cost has increased by rupees 400. So if we crash any project, what happens is direct cost increases while the indirect cost reduces. Okay, 22 into 800, that will be 17,600, and total is 57,000. So earlier we were getting total cost as 57,400, which has now reduced to 57,000 only. So there is benefit of crashing the project for 1 day. Now we have to go for the second stage of the crashing. Now look carefully. After the first stage of crashing, there is no float available in this activity as well as this activity. Now we have two critical paths. Two critical paths means paths having no float. Okay, so what are the two paths which are having no float? Let me just mark it. First path is already A, B, C, E and F. First path is this one, which is having no float at all. That means it is the critical path. Earlier AC was having the float, that that is why that it wasn't included in the critical path. Now this A, C, E and F, A, C, E and F is also the critical path. Now you have to consider this path as well while crashing in the next stage. But also keep in mind that these three paths are parallel to each other. So while crashing, if I want to crash BC, I will have to crash AC as well as BD. So because there is no float anywhere in these three in these three activities rather to say, so we have to crash them together. Let's proceed crashing now. So we have to calculate the cost slope. Now we have two critical paths, ACEF and ABCEF. Therefore, we have various crashing alternatives. Okay, I have already told you as BD is parallel to AC and BC, and we have to crash them together. So let's first calculate the cost slope of AC, BC, and BD. So AC, BC, and BD. These three activities will be crashed together. So what will be the cost slope of these three activities? Let's calculate that. What is the cost slope of AC? Is 1,000 rupees. Cost slope of BC is how much? 400 rupees. And next is the cost slope of BD, it is 500 rupees per day. That means it is 1,900 rupees per day. So if you want to crash this combination, you have to pay a surplus of, I'm sorry, it is 1,900 rupees. 1,900 rupees per day. Meanwhile, what is the cost slope of CE and EF? So CE and EF, what is the cost slope of these two? So CE is 600 rupees per day. And EF is how much? EF is 700 rupees per day. So what is the minimum amount out of these three? So obviously minimum is CE, which is 600 rupees per day. So let's crash CE. Now here it is very important to note that CE original normal duration is 9 days while the crash duration is 4 days. So we can crash it for 5 days. We have a crashing potential of 5 days. But If we reduce it for 5 days, look at the parallel activity, this one, DF. DF, how much is the float for DF? From 18 to 22. How much is the float? 1, 2, 3, 4. It is having, DF is having a float of 4 days only. We cannot crash it for more than 4 days only, while there is a crashing potential of 5 days over here. So what we will do, we will only crash it for 4 days and not 5 days. So after crashing it for 4 days, what will happen? This 9 will become 9 minus 4, that is 5. 5 means 5 normal days. And this E will shift to, this E which is lying at 16 will shift to up 12. Let's do that. So look here. After crashing, 9 has changed to 5, and E, which was earlier at 16, has shifted to 12 after crashing. Now, the float which was available for DF has vanished now. There is no float now. It is exactly 7 plus 11, which will give you 18 days. And F activity has also shifted to 18 days. Now let's see, after second stage of crashing, what has happened. The new project duration is 18 days. What is the direct cost involved now? So earlier, after crashing, the direct cost was 39,400. Now we have crashed our activities for 4 days. So direct cost will be 4 into 600 per day, which was the cost slope, right? It was the cost slope for CE. 4 into 600, and if we add them together, we'll get 41,800. This is the direct cost, which is going up. Now, what will be the indirect cost? Indirect cost is 18, because the final project is completing at 18 days. 18 into 800, it will cost you 14,400. So it is going further down, right? Let me check. Earlier, in the first stage of crashing, the indirect cost was 17,600, which has gone down to 14,400, right? And the total cost of the project is 56,200. So it started with, earlier it started with, before the normal cost of the project was 57,400 before crashing. Let me just show you this one, 57,400. Now after first stage of crashing, it was 57,000. It was 57,000. And after second stage of crashing, it came down further down to 56,200. So the cost is coming down. Let's continue our crashing and let's see the third stage of crashing. Now observe that all the paths have become critical. In all the paths, there is no float anywhere present. So whatever path you choose, it is a critical path. So in total, there are 5 critical paths now. Let's see what are the critical paths present. First path is A to C, E and F. So it is A, C, then E, F. Next critical path will be, let's continue with this only, A, C, then you go to D and then F. So next critical path is A, C, D, F. So any path can be crashed now. All are critical paths because no float is present anywhere. A, B, C, E, F. This one, straight line. A, B, C, E, F is another critical path. Now the next critical path is A, B, C, A, B, C, then we go down D and F. Okay. A, B, C, then D and F. And the last critical path is which one? Mm, it is A, B, D. A, B, D, F. So A, B, D, F. These are five critical paths present. Now we can crash any one of them. Let's see which one to crash. Now look here. These three, one, two, and three. That means AC, BC, and BD will be crashed together because they are parallel. And if you want to crash CE, then DF will also be crashed. So this and this will go together. Along with, if you want to crash EF, this along with this will go together. So we have to calculate the cost slope considering these three combinations. So let's calculate the activity which is having the minimum cost slope. For the third stage of crashing, we have five critical paths which I have just discussed with you. These are the five critical paths. Now, the cost slope, I have told you AC, BC, and BD will go together, will be crashed together, rather to say AC, BC, and BD. Also, CE and DF will be crashed together as they are having no activities having a float. Also, EF and DF will be crashed together, right? So let me mark this with a white one. So so let's calculate out of these three which one is having least cost slope. So first AC, BC, and BD. AC is 1000, BC is 400, and BD it is 500. So it is 1900. Out of CE and DF, it is 600 plus 800, that is 1400. And EF and DF and EF, it is 800 plus 700 is 1500, right? So which one is minimum? Of course, CE and DF is the minimum, 1400 per day for crashing this one. So let's crash CE and DF. Uh, so this was the position after second stage of crashing. After crashing CE and DF for one day. Why one day? Because see, the normal cost is normal duration is 5 days, while the crashing duration is 4 days. So there is the crashing potential is of only one day. So we can crash CE only for one day, right? So we'll crash it for one day only. After crashing it for one day, what will be the situation? It will be fully crashed. Normal duration will be 4, while the crash duration will be 4. E, which was earlier at 12, will shift to 11. This DF will also get crashed. Earlier it was 11 days, normal duration will change to 10 days, right? So both the activities will get crashed. And what is the cost involved? It is 1900 rupees. So what will be the new project duration, which was earlier 18 days, will come further down by one day, and the new project duration will be 17 days. Direct cost will be 41,800 plus 1400 for crashing CE for one day. That will be 43,200. Indirect cost will be 17,000 into 800, which is again coming down. But the total cost is 56,800. Let's compare it with the previous crash cost of the second stage, 56,800. So it is after third stage, what it is? It is 56,800. So you can see that after a certain time, the cost is increasing. This is normal after first stage, after second stage, and after third stage the cost is increasing. Okay, let's go further ahead and crash it to the fourth stage. Now in the fourth stage of crashing, it is again all the paths are critical. It is CE is fully crashed, so we will not crash it any further. The only left activities to be crashed are EF, which will be crashed along with DF. So there is EF and DF to be crashed together, and again AC, BC, and BD to be crashed together. So what is the cost slope of AC, BC, and BD? Again, it is same as AC, BC, and BD. We are doing it. It is 1900, 1000 plus 400 plus 500, that is 1900. And cost slope of EF and DF to be crashed together is EF plus DF. It will be 1500, right? So which one is smaller? Of course, EF and DF is smaller. So let's crash it. So EF and DF. So EF is having a crashing potential of 3 days. 6 days is the normal and crash days is 3 days. And here normal duration is 10 days while the crash duration is 6 days. So crashing potential is how much? 4 days. We can reduce it by 4 days. But we can reduce it by 3 days for EF. So which one we will choose? We will choose only 3 days. Okay. So we will crash activity EF as well as DF for 3 days. So what will happen after crashing? Let's see. After crashing, uh, all the crashing potential of EF will be gone. So it will become 3 days normal and 3 days crashed. And after reducing 3 days from here, it will become 7 days and 6 days is the crash time. And F activity, sorry, event F, which is placed at 17, will come to the position of 14 days, right? So let's move on to the fourth stage of crashing. So look here, what has happened. 3 days and 3 days, 7 and 6. F, which was earlier placed at 17th day, came further to 14th day. Now the new project duration is 14 days. Now, what is the direct cost? 43,200, which was the direct cost after third stage of crashing. Plus, we have to add some direct cost for 3 days, 3 into 1500, which was the cost slope. 1500 was the cost slope, which we have calculated, right? For each day. So we are crashing it for 3 days. See, look here, it was 1500 for each day. We are crashing it for 3 days, so multiply it by 15. Whatever answer is we'll get is the direct cost involved. Now the indirect cost will be 1400 into 800 per day. It will come out to be 11,200. We'll add them together. We'll get the total cost of the project as 58,900. 58,900. After third stage, it was 56,800, which 56,800, which after fourth stage of crashing, it is 58,900, right? So the cost is increasing now. No one would like to crash it further, but let's crash it further and see what happens after fifth stage of crashing. So this has CE has lost its crashing potential. EF has lost its crashing potential. We cannot crash these activities any further. The only activity which can be crashed is this one. What is the crashing potential? It is 7 minus 3. It is 4 days. 5 minus 3 is 2 days. And 5 minus 4 is 1 day. It can be crashed only for 1 day. So the crashing potential of BD is only 1 day. So we will choose the least one of these three. So we'll choose 1 day. And 1 day crashing means how much cost will be involved? 1900 rupees, right? So let's calculate the cost slope. AC plus BC plus BD is how much? 1900 rupees. We are doing it for so long. It is 1900 rupees. Now, after for fifth stage of crashing, what will happen? Okay, so the crashing potential of this one will be lost. I'm sorry, I didn't, my intention was not to encircle this one, rather this one. So the crashing potential of BD will be gone. BC will be crashed by 1 day and AC will be crashed by 1 day. So C and D, which were earlier positioned at seventh day, see, let's check before, which was earlier positioned at seventh day, will come back to sixth day. E, which is at 11th day, will come back to 10th day, and F will be at 13th day. So this is the same thing. E has come back to the 10th day, F is at 13th day, and this is the new project days. Is 13 days. Direct cost is 47,400 plus 1 into 1900 because we are crashing it for 1 day, and the cost involved is 49,600. Indirect cost will be 13 into 800, that means 10,000 rupees, and the total cost involved will be 60,000. So after fifth stage of crashing, it was 58,900, is again increasing to 60,000, and there is no further crashing possible. So this is the last stage of crashing, and no further crashing is possible because EF has lost its crashing potential, and CE has also lost its crashing potential, and BD has also lost its crashing potential. AC and BC, these two activities, as well as DF, is having the crashing potential, but we cannot crash them because they EF and DF are parallel. If we try to crash DF, we have to crash EF, but EF has lost all its crashing potential and we cannot crash it further. So that means our entire project has reached its full crashing potential and we cannot crash it further. And the final cost after the fifth stage of crashing is 60,000. Okay. So what conclusions did we draw from this?
So we can conclude that the project can be crashed minimum to 13 days. So this is the minimum duration of the project which was asked in the question, and the cost involved for completing the project in the minimum time is 60,000, which is not the minimum amount. Let's check further. After the second stage, I think after the second stage of crashing, the cost was 56,200, which was the minimum cost, right? And the project duration was 18 days. So for keeping the cost minimum, we can crash the project to 18 days, and that is the optimum crashing. That means if I draw a cost versus time graph, it is something like this. Earlier, after first stage of crashing, after the second stage of crashing, the time was 18 days, and the cost was minimum, was 56,200. And after further crashing, what happened was, though the time reduced further, but the cost increased. Okay, so minimum, if we want to complete the project in the minimum time, the minimum possible time is 13 days, but the cost will be 60,000. And but if we want to complete the project at the optimum time, that is, we have to minimize the cost, then the optimum project duration is 18 days, and the optimum project cost is 56,200. So thank you for being patient and learning this chapter. I hope you enjoyed this session. That's all for today's class. If you like the session, please don't forget to like and subscribe my channel. Bye bye and have a nice day.